In this video, we're going to look at how to graph piecewise functions using the Desmos graphing calculator. Okay, so as we've seen in the other videos, a piecewise function is just a function that's divided into more than one piece, more than one function. So you have the function written on the left, and then on the right you have the condition that must be satisfied for that function. So in other words, when I graph this, I'm only going to graph the function x squared minus 1 for x values that are less than or equal to 1. I'm only going to graph the function 3 for x values that are greater than 1 but less than or equal to 2, and then the function negative x plus 6 for values when x is greater than 2. So I'm going to have 3 pieces to this function. One thing that I want you to do is color code your piecewise functions. So I'm going to go ahead and I'm going to take blue, and I'm going to say when I graph this function, I know that it's got to have a closed circle in it, and less than means left. So think about when you graph on the number line, this function is going to have a closed circle and it's going to be graphed going to the left. Now I don't know what that function is going to look like yet, but I do know that it'll end with an arrow on the left side and a closed circle on the right side. Okay, now I'm going to take red. My red function is going to be the 3. I know that I have an open circle on the left of this function and a closed circle on the right of this function because of the equal to. So I'm going to have an open circle on one side and I'm going to have a closed circle on the other, and then we don't know what the middle is doing yet until we graph it in Desmos. And then green is going to be my last function. It does not have an equal to, so it's going to be an open circle, and greater than means I'm going to go to the right on the x-axis, so this graph is going to go this way and end with an arrow on the right. So when we graph this, our graph should not overlap any vertically because this graph still has to pass the vertical line test in order to be a function. Alright, so we're going to go to Desmos and type these in. There is a special way that you have to type them. You have to type y equals set notation. You put your condition first, then you put a colon, and then you put your function next. And then you put a comma, and then you do the same thing again for however many functions you have. So then I would do the condition next, colon, the function, comma, and then I'll keep on going. And then I'm going to close it off with another set notation. Okay, so remember that our condition is this part and our function is this part. So I'm going to go over here to Desmos and I'm going to type in y equals set notation. My first condition is x is less than or equal to 1. Then I'm going to put my colon, and then my function is x squared minus 1. Okay, so there's the first piece of my graph. Alright, I can change the color of my graph somehow. I can't remember right off the top of my head. I think if we hit settings and then we hit color, I'm going to change it to blue since I color coded mine to be blue. Okay, now I'm going to go to my next equation. Okay, I'm going to do y equals. Now, there's 2 ways I could do this. I said that you could put a comma here. You can put a comma here and keep on going and put them all in one box. But if you want to color code them so that each one's a different color, then you can separate them and do a new box. So I'm going to do y equals set notation. My next condition is 1 is less than x is less than or equal to 2. Put my colon in there, and then my function is just a 3. Okay, now I don't want this one to be the same color as my last one. I color coded mine to be red, so I'm going to go over here and hit settings, change this to red, and I'm done with that. And then I'm going to put in my last one. This one's going to be green. we'll do y equals set notation. My condition is x is greater than 2. Put the colon in there, and then my function is negative x plus 6, and then close off my set. Okay, and that one came out green, so that's good. Alright, so this is what we want to graph. Now it can be overwhelming to look at each graph, or look at all the graphs at one time. So if you ever want to look at just one, you can just click on these and it deletes those. It doesn't delete them from over here, it deletes them from your graph. So this is the one we want to plot first. Okay, so I'm going to take my blue colored pencil and I'm going to start plotting this graph. I want you to show me several distinct points on the graph. I don't want you to just say, well, that looks like part of a parabola, so I'm just going to come over here and draw a curved line. I need to see exactly what points this graph goes through. So remember, we said that our function is going to have a closed circle on the right side and then an arrow on the left side. So my closed circle would be this point right here in Desmos, which is the point 1, 0. So I'm going to go ahead and put a closed circle there in blue. And then I'm just going to pick a few more points to kind of shape this curve. It looks like it goes through 0, negative 1, so I'm going to put a point there. Looks like it goes through negative 1, 0. I'll put a point there. Let's try to get one more. We want to try to get good points. It looks like this one right here may be a good one. I'm not sure. Yes, negative 3, 8. So if we go to negative 3, 1, 2, 3, 4, 5, 6, 7, 8. And there's another point for that one. So now you're just going to connect these up. And we said that it's got to end with an arrow. So it's going to end with an arrow. Now obviously this is not the best drawing, but you get the idea. So there's the first piece of our function. Okay, now I'm going to go to the red piece, which is the middle piece. So I'm going to block this one out and I'm going to put the red one up. Alright, we said that the red one has to have an open circle on the left and a closed circle on the right end. So if I click right here on the left, notice how it says 1 undefined. Undefined means it's not included, and it showed me a little open circle there. So at the point 1, 3, I'm going to put an open circle. So 1, 2, 3, open circle. And then this end is at 2, 3, and that's a closed circle. And in between it's just flat, so I just have a little flat piece right there connecting the open circle and the closed circle. Alright, now let's go to the last graph. I'm going to show that one and take the red one away. Alright, for the last graph, we said it's going to have an open circle on the left and then an arrow to the right. So if I click my furthest left-hand point, notice how it says 2 undefined. I'm holding my cursor down and it shows me an open circle. So at 2, 4, let's put an open circle. And then I just need some more points to form this line. Right there's a good one at 6, 0. Let's get a couple more. It looks like right here at 10, negative 4. 10, negative 4 is a good one. Okay, so that would be here. And obviously we can see this one's a straight line. So once you get 2 or 3 points, that's enough to make a good straight line. So we're going to connect those up and make sure we have an arrow on that side with our open circle there. So that's your piecewise function. Now a couple things that you want to check when you're done. Make sure that your function still passes the vertical line test. I should be able to draw a vertical line through my graph anywhere and not cross it twice. The only exception to that is when I have an open and a closed circle that overlap each other. For example, if I drew a vertical line right here, I would hit my graph twice, but this is an open circle and this is a closed circle. So the only one that really counts is the closed circle. The open circle, remember, is not included, so that does pass the vertical line test. Same thing right here. If I drew a vertical line here, I'm crossing it twice, but one of those is an open circle, so it doesn't count because it's not included. So this does pass the vertical line test. Another thing that you may be asked about your piecewise functions is if they are continuous or discontinuous. Continuous means I should be able to start on the far left side of my graph and trace the entire graph with without ever having to pick up my pencil. Okay, but obviously I see that when I trace this graph, when I get here, I have to pick up my pencil to get to the red one. And then I have to pick up my pencil again to get to the green one. So this is not a continuous piecewise graph, it is discontinuous. All right, let's try one more. Okay. Again, I want to color code. So I'm going to look at my function down here. My first piece is negative x squared plus 5. X is less than negative 1. That is an open circle because there's no equal to. So I know that for blue I'm going to have an open circle, and less than means left, so I'm going to graph that way. Graph in the left direction. Okay, for the middle, my two endpoints in the middle are negative 1 and 4, and neither one of those have equal to's. So they're both open circles. So I'm going to have an open circle on each end with a graph in the middle. We don't know what that graph is yet. And then for my green one, it's also an open circle. Okay, so I'm going to have an open circle, and I'm going to go to the right because it's greater than, so that graph is going to go in that direction. Alright, so let's go in Desmos and type these in. You can leave the shell in there from your other ones if you want to. My first one is x is less than negative 1, so if I just stick a negative in there, change this to a less than sign, and then change my function to negative x squared plus 5. And click on that so it shows up. So there's the left piece of my graph. Okay, for the middle piece, my function is negative 2, so I'm going to change that to a negative 2, and then my restrictions, or my condition, is negative 1 is less than x is less than 4. Alright, so there's that piece. And for my last one, my condition is x is greater than 4, and my function is the square root of x. So I'm going to come down here and hit the square root of x. Alright, so this is what I'm graphing this time, okay? But again, I only want to focus on one at a time, so I'm going to go ahead and take those away, and let's just do the blue one first. Alright, now we said, looking at our graph, that this would be an open circle on the right, and then we're graphing to the left. So this furthest right-hand point, which is right here, should be an undefined point. So if you click it, it is. Negative 1, 4 is undefined. Okay, so I'm going to go to negative 1, 4, put an open circle since it's undefined, and I just need a few more points going to the left. So here's one. Actually, that's not a good one. Let's try to find a good one. If you can't find a good one, you can estimate. Okay, so this is negative 2.20. So negative 2.20 would be about right here. Let's find a few more. This one looks like it might be a good one. Sometimes it's hard to hit it right where you need it, but it looks like that's about negative 3, negative 4. There it is, negative 3, negative 4. We can try to find one more if we want to right here. This might go off of my graph, but we'll try. It looks like that's about negative 4, negative 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's way down here. Okay, so we're going to go ahead and connect this up. Now notice this is not a straight line. It's got a little bit of a curve to it. That's because if you look at our function, it is a quadratic function. It's not linear. So when you draw this, make sure you show that it does have a little curve to it. It's not a perfectly straight line. Okay. And there's that piece. Okay, so now we're going to go to the middle piece, which is red. Okay, so that's this one. Alright, if we look over here at our equation, we said that it's going to have an open circle on the left and an open circle on the right. So if I click here, it should say undefined. Negative 1 is undefined, but it's down at negative 2. So at negative 1, negative 2, I have an open circle. And then over here, this one should be undefined as well, and that one's at 4. So 4, -2 is undefined. Open circle, and then in between this is just a flat line. Both of these examples had flat horizontal lines in the middle. That's not always going to be the case. It just so happened that these two had that. So your middle graph does not have to be a flat line. And now let's look at the last one. Alright, for this one we said an open circle on the left, and then we're going to graph to the right. So this should be an open circle at 4, 2. So we're going to go to 4, 2 and put an open circle. Let's get a few more points. It looks like this one's a good one. 9, it looks like it's a 9, 3. If I can hit it in the right spot, it would show me 9, 3. There it is, 9, 3. And that's about all we can fit on here, because this one kind of goes off of our graph. And it does have a little bit of curve to it as well. It's not completely flat, or it's not completely straight. It's a square root function. It's a radical function, so it does have a little curve to it. So kind of curve that out. Alright, so let's check and make sure our graph passes the vertical line test. The only places that would be questionable would be right here, but both of those are open circles. So we're good, and right here, and both of those are open circles, so we're good there as well. Remember, one of them can be closed, but they can't both be closed and pass the vertical line test. This is another example of a discontinuous graph, because if I were to try to trace it from left to right, I would have to lift my pencil to go to the next one, and lift my pencil again to go to the next one. One more thing that's important whenever you're graphing these is if you happen to have an open circle and a closed circle that fall on the same point. So for example, when I was graphing this green one, let's say instead of 4, 2, let's say that point was 4, -2. And let's say it was a closed circle. If you ever have a closed circle that falls on top of an open circle, you go ahead and close it in. The closed circle takes precedence. And that would be an example of a continuous graph, because that means that one piece would flow right into the next piece. And if they all connected up like that, that would be a continuous piecewise function.